Hello and welcome. This is going to be our lecture video for April 24th. Let's go ahead and get started. With this due now, I want you to try to write out the sample space of all the possible outcomes of a plate appearance in baseball. So when we write down a sample space, we got to always use curly brackets. Also make sure today's date is at the top of your notes. So we use curly brackets and then we separate out the different possibilities with commas. So what could happen? You could hit the ball and get a single, a double, a triple, or a home run. Those are always good. Single, double, triple, or home run. You could get struck out. Struck. Like struck's got a C in there. You could get a walk. What else could happen? You could get hit by pitch. So that's a different way to get a walk. You can get a walk either on balls or hit by pitch. You could do a pop fly and get out that way, which is different than a strikeout. A strikeout is where you swing and you miss the ball, pop fly, you hit the ball, but somebody catches it. You can get thrown out at first. All sorts of things. I bet we could think of a bunch more if you guys were actually here, but I think I'll just leave it there. Okay. So next, we're not asking for a sample space, we're asking how many possible outcomes. So we got a hockey team that plays 5 road games, and they can either win, just an outright win. They can lose in overtime, which in hockey is still worth a point when it comes to determining who goes to the playoffs and what the seeding is. Losses in overtimes, those points do really add up, or you can just outright lose. So it's a loss in regulation. So how many possible road trips could we have? We could win all of them. We could win 2, have an overtime loss, and then lose 2. How many possibilities? So we've got game 1, game 2, game 3, game 4, game 5. For each game, we have 3 possibilities: a win, a loss, or an overtime loss, which is often abbreviated OTL. So that's 3 possibilities. So to figure out the number of possibilities for 5 games, you do 3 times 3 for the first, times 3 for the second, times 3 for the third, times 3 for the fourth, times 3 for the fifth. This is the same as 3 to the fifth, which is equal to 243 possible outcomes. Now, the number of different points you could take away is far fewer, because win-win, loss-loss-loss is worth the same number of points as loss-loss, win-win-loss. This is how many unique combinations we can make where order does matter. Okay, next one. How many possible outcomes? We're trying to create a new password, so we write the numbers 0 through 9 on cards and shuffle them, and then we use the top 5 cards in order as our password. So the first card we flip over is going to have 9 or 10 possibilities if you include the 0. The next card will only have 9 possibilities because the first one's already been flipped over. That number is gone. We can't have our password start 5, 5. They've got to be different. The next one would have only 8 possibilities. The next one would have only 7. And then 6 for the 5th number. So let's see how impenetrable this code's going to be. 10 times 9 times 8 times 7 times 6. There are 30,240 combinations. All right, I'm going to stick with this problem for a second longer. How else could we have written out 10 times 9 times 8 times 7 times 6? Well, it's the start of 10 factorial, but then it stops after 6, so you get rid of 5 factorial from that 10 factorial. And that would get you this here. All right, this right here, this password problem, this is our first look at a permutation. We'll be talking about permutations today. Goal today is to understand permutations, why this helps us find the number of ways to order something. All right, so I want to try a quick little game with you. Go ahead, pick 3 colors that you think are common in flags, and I want you to think specifically about the flags that you see that have 3 vertical stripes. All right, there's a lot of these out there. If you ever watch the Olympics where you see lots of flags, we see a lot of these 3 vertical stripe flags. What colors do you think are common? Now I want you to create every 3 stripe flag possible with the 3 colors you picked. So if I want to pick red, white, and blue, I'm going to need 6 templates. You should pick something different. I'm going to do red, white, and blue. You can pick different combinations, see if you can beat me. I think that this one's pretty common, but there are a couple combinations that are actually more common. I'll tell you what they are in just a second. So we can either go red, blue, white. Well, here's how I'm going to do it. I'm going to try red in the first spot 2 different times, red in the second spot 2 different times, and then red in the third spot 2 different times. And then I'm going to try blue in the one of the 2 remaining spots. So red, blue, white, blue, blue, red, white, red, blue, blue, white, red, white, blue, red. Okay, let's see how many of these are actual flags. So I got France. France is blue, white, red. Go ahead, look at these. Did you pick a different combination? Did you do black, white, red and get Belgium? Or black, yellow, red? All right. And let's see, I didn't get any others. Here are the rest of the 3 striped flags in the world. The winning combinations were red. I don't have a good yellow. I got a new color. If I right click on this. Red, yellow, green. Ooh, that's why I don't use yellow. It really shows up. Or blue, yellow, green. These 2 combinations both have 4 instances. And they happen to be all in the same order, with the blue, yellow, red, Andorra, Chad, Moldova, Romania all go blue, yellow, red. Senegal and Mali really similar, but Cameroon is in a different order. Is Guinea in a different order? Yeah, and Guinea's in a different order. Okay, so what is a permutation? A permutation is the number of ways to order unique items from a set. The number of ways to order unique items from a set. So order does matter because we are ordering these items. We're not just picking out 5 of them. We're picking out 5 and then putting them in order. Very similar to our password problem. All right, so the notation for permutations, it goes little n, big P, little r, and these are like subscripts. Sometimes they're just written as lowercase, but they really should be about halfway below the capital P. And this n is the number of items in the set. So with our password, this was like the 10 numbers possible. All right, and then the R is the number we are ordering. So the number we are picking, we often say picking because it's a good way to think of the P, even though it stands for permutation, you could think of it as pick however many. So number we are picking to order. So in our password problem, we picked 5 numbers. Five numbers for password. All right, and it's really important in permutations, the things we put in order can't repeat. So, once we used the 5 in our password, we couldn't use it again. So often when we say these, if we're doing like an 8P, to do a P3, we say 8 pick 3. I have 8 items, I'm going to pick 3 of them and organize them. All right, so how many 3-scoop ice cream cones are possible? There are 31 flavors to pick from, and you don't repeat flavors. I picked 31 because that's the number of flavors available at Baskin-Robbins. And we're going to do like an ice cream cone like this. So not in a bowl. It's going to be scoops, one on top of another. And so it's very different if we put strawberry on top, then chocolate, then vanilla, versus going vanilla, then strawberry, then chocolate. Those should count separately. So in terms of our notation, this should be 31P3, 31 pick 3. Now let's see the math of how we calculate this. Maybe I'll put it back on this slide. So NPR is going to be equal to, you do n factorial first, then you divide it by n minus r factorial. All right, and this should make sense when we look at our Baskin-Robbins example, because you have 31 choices for your first flavor at the very bottom. Then you have 30 choices for the flavor that goes on top of that, because you can't repeat. Then you have 29 on top of that, but then you stop. So this is equal to 31 factorial divided by 28 factorial. So we started 31 factorial, but then we stopped after 28. So 31 times 30 times 29, we've got 26,970 3-scoop combinations in a cone. Okay, let's try another one. How many 5-letter arrangements can be made from the letters in the word Southern? So first off, we need to count these out. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 letters, and we're going to pick 5 of them. So we do 8P5. So this is going to be equal to 8 factorial divided by 8 minus 5 factorial, which equals 8 factorial over 3 factorial, which equals 8 times 7 times 6 times 5 times 4, but then we stop because the 3 times 2 times 1 has been canceled out, times 7 times 6 times 5 times 4 equals 6,720. All right, How many ways can a class of 13 kindergartners line up for lunch? So we have 13 kindergartners to pick from, and we pick all 13. So it's 13p13. So we are organizing all 13 of these kindergartners. You might recognize that this here is just going to be equal to 13 factorial, because it would be 13 factorial divided by 13 minus 13 factorial, which would just be a 0 factorial or a 1. So what is 13 factorial? 13 math probability number 4 is factorial. We get 622,702,800. So a little over 6 trillion, no wait, 6 billion ways for them to line up, 6.2 billion. All right. So I'm gonna go back and show you how to plug this into your calculator if you want to know how to do 31p3 in the calculator. There is a button for it. All right, so if you want to do 31p3, just type the 31, then you hit math. You go over to probability, and there's NPR right there. We pick that. It fills in the 31. Sometimes it doesn't. It just leaves it as NPR, but it's still doing the same thing. We're picking 3 of them. We got 26,970. Let's see if that matches. Our notes, good. Let's redo this one, 8p5. So I can do 8, math, NPR, 5. I get 6,720. Yep, and then we'll try 13p13 to make sure that gives us that big number, 13p13. And there it is, 6.2 billion. All right, call that good for this video, and have a good rest of your day.